Okay, it's game time. We're live. Group number, what's this? 1, 2, 3, 4, 6. Jibber jabbering. All right. Okay. A3 day 1. Today's Monday. Remember, your test is Wednesday. We're doing A3 day 2, and then just shoving a little, well, we'll call it a quiz like we talked about. Ready to go with these Algebra 2 review concepts. Feel free to write this down. I'm not going to read it to you. I put the notes online as well, so you can read this on your own. But really what the key is what I've highlighted. Domain. What is domain? When I say domain, you should say what instantly? Well, range is an opposite. Good. Domain, range. Who's domain? Usually X. Now, I'll just get this out right now. Our examples today have multiple variables, some of them. But in the classic, when we graph, we have an X and Y axis. X is considered the domain, Y is the range. But really, some better words are input, output. Who's the input, domain or range? It actually is domain. Independent, dependent. Who's independent? It's actually domain. And I'll give you, how many people work? Anyone working here? Okay, you work and you probably get an hourly wage. So when I ask you, how much do you make? You really should say, don't tell me your number, but you really should say it depends upon how many hours you work. So it depends upon how many hours you work. So what's the independent scenario for her? How many hours she works. How much money does she make? That's the dependent variable. So the input or the domain in that scenario is the hours worked. The range is how much money she makes. Correct? That's called a function, by the way, but those are classic uses of the words domain and range, input, output, independent, dependent. So when I say the word domain, I feel like I have to go through all that rigmarole. Look off to the side. There's a reason for my insanity of going over things that you think, why is he just intermittently just throwing this down there? 0 divided by 7. What's the answer to that, by the way? 0. And everyone's been trained and classically knows that that's 0 and that's okay. Here's the reason. This is a division garage, everybody. Remember grade school? When you divided by numbers, you put 1 in the garage and 1 on the outside of the garage. Who goes on the inside of the garage? Not the big number, but 0. And then 7 goes out here. Then you ask yourself, what number times 7 equals 0? Is there a number times 7 that equals 0? Yeah, what number is it? 0. So there is a number that exists for this. This is why there is an answer. This has to do with domain, what we're going to be doing today. All right, and then you can subtract this, you get an answer, and that's the answer. So, not to belabor this too long, in this example, 7 divided by 0, 7 goes on the inside. 0 goes on the outside. What number times 0 equals 7? What's the answer to that? There isn't one. This is impossible. So this is the one that you do not get an answer for. This is a mathematical impossibility. All right, this bridges into what you're going to have to be doing for domain today. I'm going to pick groups. We have 6 examples. 6 groups are going to talk about those examples. So it's going to be your own personal notes. So by the way, what do you think 0 divided by 0 is then? Ooh, that's an interesting question. Some people might say 1. That's ridiculous. Sorry if you were thinking that. But is it 0 or is it undefined? And it's actually a classic thing for you to think about and probably say 0. And that's actually not true. It is undefined as well. So 0 divided by 0, if you type that on your calculator, you will still get a divide by 0 error. Right? Go ahead. I have some people hitting that on the calculator. Okay? So look at the first set of directions, which is, I believe, what your homework says. Just find the domain. Well, everything I just covered dictates what happens here. Domain is what can I plug in for these variables. Notice this second example doesn't say x, it says n. Don't overdo that too much. But when they say, what can I plug in for x, you're actually going to list what can't happen. And that's how we're going to actually approach this. So I'm going to pick some groups. You guys, okay, hold on. You guys talk amongst yourselves. What do you have to do for example 1 in order to maybe get it ready to figure out what I can or cannot plug in for x? And then I'll pick a group to get on here with the calculator. So, give you a little hint. Factor. And then what can't I have? I can't have a what where from my little red over here. I can't have a what where. 0 in the denominator. Okay, now the second one's a little different. And I will pick a group for that. Actually, I don't know if I even pick groups for this. The other hours. So, we'll see. So, factor, and then say what can't x equal in the first one. Oh, and the video's still. So, number 9 got picked for the first one. Factor. Who factors? Numerator or denominator? Go. What is it? What is this in factored form if it's just denominator? Yes? Okay, now, do you know what x... Now, this is your Algebra 2 answer. And then depending on your Algebra 2 teacher last year, some claimed in the other hours they didn't learn this, and some claimed they do remember this. But let's do the Algebra 2 answer for this. What you have to say for the domain is what can't x equal based off of what we, listed up there as far as dividing by 0. So what numbers, when I plug them in for x, I get a 0 in the denominator? The 0 is 1, and what's the other one? There is one more. Oh, you should go. It's your turn now. 0, and then look at the other fact. What if I plug this number in here, and then that number turns that into 0? So what number turns this -3? So that is the domain. In Algebra 2, a non-equal sign actually means every other number but these. Okay, so that is good. But now we're going to go to cat. Meow. This is called interval notation. Okay? Look at a number line. I'm pointing in the room to the left. What number is all the way there on a number line, the farthest one that you can think of? Very small. What number is over there on the number line? Negative what, though? Negative infinity. All the way to the right. What number is that on that side of the number line? Positive infinity. Okay, so hopefully this spurs a memory of how you answer questions as opposed to an inequality. So what can x equal? It can equal everything but 0 and -3. So it can equal anything from negative infinity all the way up to, you have to go in order of a number line. So who comes first, -3 or 0? -3. And then does anyone remember what I put on -3 to not include it in interval notation? By the way, who knows what this interval notation is? You're kind of getting some memories on this? All right. What do I put on -3 to not include it? It's a parenthesis or a bracket. Which one is not including? Do you remember? No? It's actually a parenthesis. The same problem happened last hour. They said bracket. No, parenthesis does not include. And then this is what's weird about this. What does that stand for? It's a U. That means union or together. Who just said together? It's awesome. Okay, then what do you have to put next? This is going to be silly for you. You have to put -3 again, because with these parentheses, it just means it excludes -3 within these intervals. And then what's next? All the way up to 0. And then 0 off to what? Positive infinity. That is a mouthful. That's actually a lot, and it is kind of annoying. But when we get to chapter P, it's going to be all interval notation. And what you're saying is this. Instead of just a lazy not equal to sign, you have physically listed all the numbers that you can plug in for x for this function. All right? And all this says is everything but -3 and also not 0. Saying a mouthful there as well. We're on to the next one. Can't take the square root of a negative. Can you take the square root of 0? What is the square root of 0? Oh no, what's the square root of 0? Oh no, what's the square root of 0? What's the square root of 0, everybody? I got caught. I'm stuck. I must have had a tragedy in class. All right. So you can take the square root of 0, and the square root of 0 is 0. So what am I getting at? What can we plug in for n? Can we plug in 4? Yes? Can we plug in 5? I'm scaring the students. 6, 7, 8. Who do we appreciate? 3. Can I plug in 3? 2, 1. Blast off. All right. So, can you put that in an inequality? What n can equal then? You guys. Nope. And we're not going to do that notation yet. Let's do the algebra 2 notation. Okay? I'll let you think about it first. True. I'll put this on the table. It's true. I don't care how complicated it is underneath the square root. What you have to define what's underneath that square root is that it has to be 0 or positive. So this expression must be greater than or equal to 0 when it's evaluated. Otherwise, I'm taking the square root of a negative, which is naughty. Now, how do you write that in interval notation? Well, where's to the right of 4? What number is to the right of 4 very large? Infinity. So, and then what do I put when we include 4? Not a parenthesis, an actual what then? And it has to go in order. 4 to infinity says the exact same thing as that inequality in interval notation. Now that's a little bit better. A little bit better looking. Oh, and by the way, you should be asking, why does infinity have a parenthesis when you're actually getting there? You can't get to infinity, can you? What happens if you think you gave me the biggest number in the world? What can I always do to that number? Add 1 or multiply by 2 or whatever. So the concept of infinity can't ever be achieved, so it can't ever truly be included. That's the theory behind that. Brackets mean including, parentheses mean not including. So that's why infinity and negative infinity always have a parenthesis. Great timing. Just hit the play when the bell went on. All right, here we go. So this is what the next phase is, really what this is getting to, reducing fractions. Now again, we said domain is x, and here we have an n and we have a y. We'll talk about what can be inputted here, or what can't be, is really what I meant to say. But what you're going to do is simplify fractions, which is done by the process of factoring. So I have 2 examples. I'm going to leave you guys alone to discuss, and then I'm going to randomly tell you which groups were picked to discuss these. You're going to factor. You're going to cancel common factors. But actually, what you should do before you cancel factors is to determine your domain exclusions. The reason is, what did I say 0 over 0 equals, everybody? What did I say up there? It is not defined. So when you take a set of factors and then cancel them, and then exclude them from domain exclusions, you're actually doing this bad math off to the right. Because we're talking about the original. Before you factored and canceled, what are the domain exclusions? All right, I'll leave you alone for a second. Okay, we're going to go to a group. I'm pulling one up on the calculator, and then we'll show what they got for solutions at the end. So we'll keep this off. It's factored. We factored out the n out of the bottom. Talking about. So now here's the exclusions in set builder notation. Now we're going to attempt interval notation. So what do we start with? We always start left of the number line. It's got to be in order. What's the smallest number ever? Negative infinity all the way up to what works? Go in order, perfect 0. And then you union that with 0 again. I'll help you on that one because that's kind of weird. You got to bridge it. This excludes it though, really. To who? 0 to 2. And then you bridge it to 2 to infinity. And there are parentheses all the way across because we're excluding 0 and 2. So it is lengthy. It's a little bit annoying to write all that out, but it is what it is. Quick question. Okay, now, so when you look at this, is 0 any longer a problem? And the answer to that is no, but here's where 0 is a problem, in the original. When I plug in 0 into the original question, I get 0 over 0. And 0 over 0 is an undefined output value. So that makes 0 plugged in for n still a naughty value. So you always do domain before you cancel. So that's why I label that as step 2 before you cancel stuff. All right? So we factor by grouping, and group 6 is finishing it off. Go ahead. 5. Group 5. So you pull out a y squared, and you have y plus 2. Back to the original. What are our domain issues? Now looking at that factor denominator, what can't y equal? 0 and negative 2. Next, how do you put that in interval notation after our glorious explanation from the last one? So instead of y cannot equal, we have to say what y does actually equal. Remember, start over here. That number, which is to all the way up to what going in order. And then what do I have to do to negative 2? I put a parenthesis, but then what do I do? U? And then who goes next? It's still negative 2. To what? Get in there. Then what? Me? And then what? Never mind. Stupid. Ugh, it's annoying, but it is what it is. Last but not least, now let's actually cancel. So who cancels? Who cancels happily? Whoa, another group's taken over. It's a fight. All right? Who cancels? Who's exactly the same thing on top and the bottom? Y plus 2. Chapow. Now I'm going to write this like this to ask the silly question again. Should I cancel these y squareds, yes or no? Never! Sorry for yelling along the way. So, group number 8 got picked for example 5. Let's not be ridiculous. N plus 3 can't factor. But what you should do is lock it in parentheses and look for another n plus 3 later. N minus 1, not right now. But look at this. These are close. So did you do something about that 1 minus n? What'd you do? Absolutely. Awesome. You're the first one all day long that has done that. They are called opposites of each other. What does the 1 minus n become when you pull out a negative 1? Now, the other groups, they said they multiply by a negative 1, but you were the first one to say pulled out, which implies factoring a negative 1, which is correct terminology. And then what about the bottom flip? Next person. What does n squared minus 9 become? N plus 3, n minus 3. And then just for giggles, we'll verbalize this. What can't, there's some people giggling over there. What can't n equal? N can equal what, everybody? 1. What else? And what else? Positive 3. So 3, negative 3, and 1 are what the domain would be in this case, the domain being the variable n. Now, who cancels? Yeah, you haven't got. I almost elbowed you. Sorry about that. Who cancels? Sorry. N plus 3s, and I'm stuck. N minus 1. I'm having a lot of troubles today. And then what's your final answer? Negative 1, right? Over n minus 3. And I'm scuffling here, so I got to get myself back in focus. Okay, factor the numerator of the first one. Go ahead. Next, let's not be ridiculous. Nothing happens on the bottom. But what do you do about this? And then what do we write next? Okay, now let's talk about domain before we continue. Actually, in the division statement, this is a little bit annoying. You do have to talk about before you flip, and then after you flip, domain issues. So I should concentrate on that, these, and these. So what can't y equal in either case? And actually in this case either. In all those cases, y cannot equal what? 0. And then what can't n equal? 0 after it was flipped. So that's how you do domain. Even in a division statement, wherever anything is in the denominator at any point, you need to associate what is the domain for that. It's a pain. I got you. Back to you. Who cancels? Let's start hacking apart now. Oh, something does definitely cancel. Do you know? Did you get something personally on your page? Oh, something cancels. They're all standing alone. Okay, so nothing. The y minus 3 is there's no other y minus 3, but who cancels? Yeah, so how many y's cancel? Okay, so I can cancel this with who? The 14y like that y. But look at this. This is a y squared, which is y times y. and there's another y down there. This is often messed up by students. So how many more y's cancel? Kind of gave it away. Well, actually, one set of them. So this cancels to be y, and this goes away. Now this gets ugly. Your final answer is actually 3y times y minus 3 up in the numerator over, and then it's just 14 times 2. And the reason 28 doesn't cancel with the 3 is because 3 doesn't go into 28. 3 doesn't go into 14. 3 doesn't go into 2. But if it did, you better cancel it. And there's also an n down there. So that is the simplified final answer. The last group to go is group number 7, and then we're almost done. Who's 7? We're 7. Where are they? That's you guys. First things first. This doesn't really change. This doesn't really change, but what you should be aware of is it means it's written by times itself, right? So just be aware of this for canceling. Times, this is what I'm interested in. Times what fraction? You start. Who goes up in the numerator now? Absolutely. So this is divided by numerator over denominator. You flip it when you turn it into a times. And then this becomes 8xy. Oh, this is going to give me a headache. But what can't x equal? 3. What can x equal? And it doesn't make anything different. Still 3, even though it flips. But then what else can't x equal? 0. And then what can't y equal? Ugh. Then you'd have to write that all and just leave it in algebra 2 cents. All right, then after all this, who cancels? And x minus 3 cancels. I should put that in parentheses. Then you got to be careful on this. Who else cancels? Go ahead. 1x, so you got to be careful with knowing there's an x left over on top. What else? Keep going. A y. Maybe destroy them like that. And does anything else cancel? 2 and 8. Both ours, first and fifth, did not do that at the end. 2 over 8 is 1 over 4, and I really don't like how I wrote this. This gets really hard to keep track of, so be careful in canceling this way. You sometimes lose some stuff. But when I look at the numerator, I have a 1 and an x, and everything else was destroyed. So it's 1x, or just x. Then when I look at the denominator, I just have a 4 and an x minus 3. 4 times x minus 3. And that's ultimately what we're trying to do. All right, and then as an exit, I did do this, and I feel like we should still do this. Oh, yeah. Take a look at this last one, because this is really a good Algebra 2 question. Group number 5, what do I do with this 3 minus x? Take out a negative 1 is correct. What do you have left over? X minus 3. Group number, who was next? Who had to factor this bottom? Where are we at? Who was this? Do you know it? Well, let's check it. X minus 5, and what'd you say? Now, the reason that can't be, and this is fine. This happens, though, but you better check. What's negative 5 times negative 1? Ooh, yeah, she did the same thing. All right, so is that correct? No, so something's got to change. What do you think it's got to be? I think you're actually really close. Come back to you, all right? And then that's why group number 5, who did this first, pulled out a negative 1, because now I see a match. We still got to make this change. Have you guys gotten it yet? Okay, it's just one minor little thing. And then who had the 2x squared minus 15? Okay, what's that factored? Times what? X minus 7. Good. Good FOILers are good factors. You could refoil that and check that. That's why I know this group is wrong, because negative 5 times negative 1 is not negative 5 there. One minor change. Wow, make that a plus, you mean? Yeah. Gotcha. All right. So he said put a little vertical line through that horizontal line. Awesome. Okay, so what can't x equal? Holy crap, we got a whole bunch of stuff. Let's, just verbalize it. X can't equal negative 5. X can't equal a half. Be good with solving individual factors. This used to be in the bottom, so x still can't equal a half, but x also can't equal 7. And then x can't equal 3. A lot of restrictions. With all that being said, who cancels? This is the fun part. Get medieval with it. Who cancels? X minus 3s. Ah! Who else cancels? Blah! Okay, use your frustrations and get angry at the math. Final answer. Close those parentheses.